Good day, students. Welcome to mathgoodstuff.com. In this clip, we're going to be going over how to find the average rate of change of functions. This is section 3.1 of our virtual calculus text. Before we get started, let's take a look at the formula that's going to be guiding our problem solving process. Okay, so the formula for the average rate of change we're going to call this AROC, okay? Average rate of change. The formula for calculating the average rate of change can be given as the average rate of change, let's write it as AROC, of some function f on an interval. Let's say the interval is from a to b, okay, is given by f of b minus f of a divided by b minus a. Okay, this is a calculus formula that can also be written as an algebra formula. Okay, so if you look at f of b minus f of a, that represents your rise, and b minus a is your run. So if you think about algebra and the formulas that you studied then, which formula is rise over run? It is a slope formula, correct? So this is the same thing as y2 minus y1 divided by x2 minus x1. So the average rate of change of a function on an interval is the same thing as the slope of the secant line to that curve on that interval. Okay? So let's go ahead and write this. This is the same thing as the slope of the secant line. We can call this SOSL. Alright, so don't forget, whenever you're looking for the average rate of change, you're also looking for the slope of the secant line on that interval, which is the same thing as the slope, y2 minus y1 over x2 minus x1. So let me just give you a visual of what I'm talking about. So let's say we have a coordinate system and some random function. So let's say this is the graph of f. And then let's say f is something like this. Okay, and then we have an interval. We're going from a to b, so this is a right here. And we want to find, let's say we're asked to find the average rate of change of this function from a to b. So if you want to resolve this problem graphically, all you simply have to do is draw your secant line through these 2 points and calculate the slope of this secant line, and that is your average rate of change. Okay, so this line right here, let's call the line L. So this is line L right here. So what we're saying with this formula is that the slope of the secant line of this line is the same thing as the average rate of change, okay, which is also the same thing as the slope of a secant line on that interval. They all mean the same thing. All right. Okay, let's take a look at an example. So for question 1, we're to find the average rate of change of the given function. Find the average rate of change of the given function over the specified interval. So when you're looking for average rate of change, you need an interval. You can't find average rate of change at a point. It has to be an interval. So let's say we have the function y equals negative 2x squared minus x plus 2. All right, let's do it. So what we're going to do first is let's go ahead and write down the formula that's going to guide our problem solving process. So the formula is the average rate of change of a function f on the interval AB is given by f of b minus f of a divided by b minus a. So this formula tells us that we need 4 pieces of information, 4 numbers to find the average rate of change. We need f of b, we need f of a, we need b and a. Okay? In order to find f of b and f of a, we need the function and the b and a values. So let's go ahead and write down what we have so far. Let's start with the independent variables. A is, let's say, I didn't finish the question. Let's see, we're finding the average rate of change on the interval 0, 1. Alright, you can do it without an interval. Alright, so A, you have 0 and 1. If you think about the alphabetical order, A comes first before B. So on the interval, it has to be written in ascending order, which is standard. So A is going to be the smaller of the two. Okay, so A is 0 and B is going to be 1. So we're going to plug this into the function. Let's rewrite the function. So y is equal to f of x, we all know that, which is negative 2x squared minus x plus 2. Okay, so we have that. Now we want to find f of b. F of b, we're just going to take the b value and plug it into these x's here. F of b is the same thing as f of 1, which equals negative 2 times 1 squared minus 1 plus 2. Let's simplify that. We have negative 2 minus 1 plus 2. And our final answer is going to be negative 1. Negative 3 plus 2 is negative 1. One last piece of information we need is f of a, which is equal to f of 0, because a is 0. And then we evaluate this function by plugging 0 into the x's. So we have negative 2 times 0 squared minus 0 plus 2. When we simplify that, we're going to get our f of a value, which is 2. Alrighty. Okay, we have all the ingredients that we need. Now let's go ahead and write down the formula again. So the average rate of change of this function f from where to where? From 0 to 1 is given by f of b, which is 1, minus f of a, which is 0, divided by 1 minus 0. Alright, we already know what f of 1 and f of 2 are. So f of 1 is negative 1. F of 2, I'm sorry, f of 0 is 2. So we have negative 1 minus 2 divided by 1 minus 0, which is just 1. And then if you PEMDAS this expression right here, you get negative 3 as your average rate of change. Alright, so the average rate of change of f or y on the interval 0, 1 is negative 3. So, okay, so that's that. Alright, let's take a look at another example. Now for this one, let's say, number 2, you're to find the slope of the secant line to the function y equals 1 over x plus 1 on the interval 1 to 2. Alright, let's do this. Alright, so we're going to get started by writing down the formula for the slope of the secant line. So what did we talk about earlier? The slope of the secant line is exactly the same thing as the average rate of change that on that interval. Okay, they're one and the same. So the slope of the secant line, SOSL, of the function on the interval a to b is the same thing as the average rate of change of the function from a to b. It's one and the same thing. Okay? Alright, let's make that blue to illustrate the connection. What is the average rate of change? Oh, we know what that is. That's rise over run. Y2 minus y1 over x2 minus x1. But if we want to use our fancy calculus notation, we're going to write it as f of b, which is y1, minus f of a, which is y2, divided by x2, which is b, minus x1a. Alrighty? So like we did before, we need 4 pieces of information to solve this problem. F of b, f of a, b, and a. Alrighty? So let's start with the independent variables first. A is the lower bound of the interval, which is 1, and b is the upper bound, which is 2. Alright, so in your interval right here, you have, this is AB. Alright, so this is A, and this is B. Alright, we also need the function. What is the function? The function, y is the same thing as f of x, right? F of x is 1 over x plus 1. Alright, so this will help us figure out f of b and f of a. So f of a, let's do f of b first. F of b, we know that b is 2, is f of, that's going to be f of 2. So what we're going to do is plug 2 into the x, this function right here. Okay, so bam. When we carry out that evaluation, we have 1 over 2 plus 1. And then that's 1/3. If you PEMDAS this expression right here. F of a, what is f of a? A is 1, so that's f of a is the same thing as f of 1, which is 1 over 1 plus 1. If you PEMDAS this, you add the denominator first and then divide the, parentheses, you do the denominator first, so you have 1 over 2. Okay, so there you have it. So we have all the ingredients that we need to calculate the average rate of change from 1 to 2. So let's go ahead and carry out the calculation. So we're looking for what? What are we looking for? We are looking for the average rate of change of f from 1 to 2. Using the formula, that's simply f of 2, which is b, minus f of 1, which is a, divided by b minus a, 2 minus 1. Okay. We already know what these 4 components are. That's what we were doing here. So we're going to put it into the formula now. F of 2 is 1/3. Right here. F of 2 is 1/3. And then f of 1 is 1/2. Divided by b minus a, 2 minus 1 is just unity. It's just 1. Alright, so find the LCD and combine these 2 fractions. We multiply the first one by 2, top and bottom, and then the second one multiply by 3, because the LCD of 2 and 3 is 6. So we just want to adjust them into the appropriate equivalent fractions with identical denominators being equal to the LCD. Alright, so it's going to give us 2 over 6 minus 3 over 6. If you divide by 1, you're going to end up with whatever you started with, so we can just forget about that. And then our final answer is going to be 2 minus 1, negative 1 over 6. Okay? Alright, so that's the average rate of change of the function from 1 to 2. Now, let's go ahead and state what our answer is. We want to make sure we're answering the question. The question asks for the slope of the secant line on that interval. So let's write it. the slope of the secant line, to the function y equals 1 over x plus 1 on the interval 1 to 2 is what? Is negative 1/6. Bam. So there goes our final answer. So how well did you understand the contents of this presentation? To demonstrate mastery, we would like you to try out the following problems. So try these. Instructions are to find the average rate of change. Find the average rate of change of the given functions over the specified intervals. Alrighty, so question number 1. Let's say we have the function y equals 1 over x plus 3 over the interval -2, 1. Number 2, what if you have the function y is equal to x squared minus x plus 2 over the interval -1, 2. Number 3, let's say we have the function y equals -x squared minus 1 over the interval 0, 1. And then number 4, let's say we have the function y equals -1 over x plus 3 over the interval -2, 1. Alright, so go ahead and pause the video at this point in time. Try out these problems. When you're done, go ahead and click on the playback button in order to see what the answers are. Hopefully you've had a chance to try out the problems. Let's go ahead and take a look at what the answers are for question number 1. The average rate of change is -1 over 4. For number 2, the average rate of change over this interval is 0. For number 3, the average rate of change over this interval is -1. And then for number 4, the average rate of change over this interval is 1 over 4. Alright, so that's that. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your studies of the average rate of change and calculus in general, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation, or if you need us to make any calculus videos for you, just post it in the comment section below and we'll be more than glad to respond. Do not forget to subscribe to our channel for updates to other parts of this virtual calculus text. More resources can be found at math.serve.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.